Hello, and welcome to a presentation by Véto-pharma. Today, we would like to talk about oxalic acid in beekeeping. More specifically, we would like to present you some of the benefits associated with oxalic acid dihydrate as an active ingredient in Varroa treatments, and we will focus on the most commonly used application forms of this substance. Oxalic acid has been used in beekeeping as a Varroa treatment for several decades. It is an organic acid, and it occurs naturally in several plant families. Wood sorrel and rhubarb are two prominent examples of plants with high oxalic acid content. As an active ingredient in Varroa treatments, oxalic acid has been investigated and used since the 1980s in Japan and the former UdSSR. However, the official authorization of the first oxalic acid treatments in Western and Central Europe was granted much later. In Germany, the first authorized treatment was available to beekeepers in 2006, in Spain in 2007, and in France in 2015. The mode of action of oxalic acid in Varroa mites is not yet fully understood. It has been suggested that the substance causes significant acidic burns, leading to severe physiological damage in the mites and eventually causing them to perish. Oxalic acid is a contact miticide, meaning that Varroa mites have to get in direct contact with the molecule in order for the substance to work and target the mites. Beekeepers must use oxalic acid treatments in brood-free or nearly brood-free colonies to achieve maximum efficacy of the treatment in their colonies. This is because oxalic acid molecules cannot penetrate the brood cap, and thus only work on phoretic mites on the bees. Mites in the capped brood are not targeted. Organic acid treatments have been classified by the EU as eligible for organic beekeeping. However, it is recommended for organic beekeepers to contact their organic certifiers to ensure that they can use a specific formulation as a Varroa treatment in their colonies. Some of the biggest advantages of oxalic acid as an active substance are, firstly, its consistently high efficacy against Varroa if applied correctly. Secondly, its recognized status as an organic treatment. And thirdly, a comparatively low risk of resistance development in Varroa mites. This is because the suggested mode of action of oxalic acid in Varroa mites is thought to be rather unspecific, which makes it more difficult for Varroa mites to develop resistances. The three most commonly used application forms of oxalic acid in beekeeping are trickling, spraying, and sublimation. For trickling, oxalic acid dihydrate solutions with sucrose and/or glycerol are trickled directly onto the worker bees in occupied bee spaces of the colony. Beekeepers use syringes or similar devices to apply exactly the required dosage for the hive. For spraying, brood frames are pulled individually and sprayed with oxalic acid dihydrate solution from both sides. This practice is not necessarily recommended for winter treatments, as it is quite invasive, but it can be a good option for the treatment of nuclei and splits in summer. For sublimation, oxalic acid powder is heated and thus transferred into gas or oxalic vapor, which is then led into the hive through the entrance. For this application form, beekeepers must take additional safety precautions, such as wearing a mask. It is important for beekeepers to use authorized Varroa treatments only to ensure the safety of their bees, the consumers of hive products such as honey, and their own safety during their treatment application. Authorized treatments have been carefully developed and tested over years before they receive the official registration as Varroa treatments. Now, let's quickly summarize some of the benefits and risks of the three different application forms. Trickling is well recognized for its consistently high efficacy. It has been rated as the quickest and easiest application form in a recent comparative field trial in Germany, and it is considered safe for beekeepers. A single application by trickling is very well tolerated by bees, but repeated applications should be avoided, as these have been observed to cause increased bee mortality. Spraying is a practical and very effective treatment for nuclei and splits in spring and summer, as well as for smaller beekeeping operations. However, it is more invasive and time-consuming than the other two application forms, and therefore not recommended for winter treatments. Spraying is well tolerated by bees after a single application, but, like trickling, not recommended for repeated applications. Sublimation is a highly efficient treatment form, which is consistently well tolerated by bees. However, it does require a higher level of protection for beekeepers, such as wearing a mask during the application. Beekeepers should beware of the equipment they are using for sublimation, as some commercial vaporizers are known to heat up too quickly, thus resulting in decreased efficacy of the treatment. Season and local climate play a role in picking between different oxalic acid application forms as well. Keep in mind that maximum efficacy with oxalic acid treatments can only be achieved in brood-free colonies. This makes oxalic acid treatments ideal winter treatments in areas with temperate or continental climate and a natural brood stop in winter. Commonly, beekeepers in these regions apply solutions with sucrose and/or glycerol, and a concentration of 3.5% oxalic acid dihydrate by trickling directly onto the worker bees in the winter cluster. The bees are sitting closely together, which makes it easy to reach nearly all of them with the solution. Beekeepers in warmer climates, such as the Mediterranean climate, often do not have the luxury of a natural brood stop in winter. Beekeepers induce artificial brood breaks here, for example, by removing the brood completely before treatment or by caging the queen for 25 days before the application. This is a widely used technique in Italy, where much of the research on queen caging and oxalic acid treatments has been conducted. In 2017, a queen caging and oxalic acid treatment field test was conducted in France. The objective was to test the efficacy of oxalic acid by trickling as a late summer treatment after queen caging. Queens were caged for 25 days in 24 honeybee colonies participating in the trial. Afterwards, an oxalic acid dihydrate solution was applied by trickling, and the mite fall resulting from the treatment was counted for 15 days after the application. The treatment resulted in more than 95% efficacy against Varroa mites within the first 6 days after application, and achieved 99% efficacy within 15 days. The combination of queen caging and oxalic acid dihydrate application by trickling was thus found to be highly effective as a late summer treatment without honey supers installed. Let's take a look at the practical advantages of oxalic acid as an active ingredient in Varroa treatments. First, oxalic acid treatments are the only class of organic Varroa treatments that are largely independent of temperature. In comparison, formic acid and thymol treatments can only be used in a smaller temperature range, because these active substances evaporate in the hive at a rate dependent on temperature. If temperatures are too high, these actives cannot be applied because they are released at higher rates and can become toxic to the bees. If temperatures are too low, the release is too slow to offer sufficient treatment efficacy. In contrast, oxalic acid is a contact miticide. No evaporation takes place in the colonies. A second advantage of oxalic acid treatments is the low risk of residues in hive products after treatment. Oxalic acid is hydrophilic, which prevents accumulation in wax. It is also a natural component of honey and occurs in a wide range of different amounts in different honeys. Residue analysis after oxalic acid treatment applications of all three application forms have consistently found only minimal and short-lived increases of oxalic acid content in honey. The low risk of resistance development in Varroa mites is another significant advantage of oxalic acid treatments. Apart from the suspected unspecific mode of action of oxalic acid, the low residues and rapid degeneration of the substance in honeybee hives plays an important role in this context. A 2017 study from Argentina demonstrated that even Varroa mite populations that had been exposed to oxalic acid treatments 64 times over a period of 8 years were still completely susceptible to the active ingredient. As mentioned before, the damaging effects of the acidic burn caused by oxalic acid on mites may make resistance development very difficult. High efficacy of oxalic treatments with all three application forms have been demonstrated repeatedly over the years. The most relevant factor for a high efficacy result of the treatment is the amount of brood in the colonies at the time of application. Beekeepers can either treat naturally brood-free colonies or perform a brood intervention before the application. Finally, oxalic acid treatments are well tolerated by bees if applied correctly. Single applications by trickling of up to 4.6% oxalic acid dihydrate solutions are well tolerated. Multiple summer or autumn applications by trickling or spraying should be avoided, as they are poorly tolerated by the bees. Some studies suggest that repeated applications may be better tolerated in warmer climates. As an additional ingredient in some oxalic acid-based Varroa treatments, Glycerol offers major benefits as an excipient in the formulation. Due to its beneficial properties, such as low toxicity, Glycerol is used for various applications, for example in the food industry, cosmetics, pharmaceuticals, or as an antifreeze. Glycerol is an organic sugar alcohol that is also naturally metabolized in the human body. It is a hygroscopic substance, meaning that it retains water. The effects of glycerol as an ingredient in oxalic acid-based Varroa treatments was first investigated in the early 2000s. The results demonstrated that glycerol is able to retain water in an oxalic acid solution at lower relative air humidity compared to sucrose as an alternative to glycerol. This allows for longer storage of ready-mixed oxalic acid dihydrate solutions with glycerol compared to solutions that contain sucrose only, as these solutions develop high HMF levels quickly and thus have to be used soon after mixing. We would like to thank you for your interest in this presentation and hope that you learned something new and interesting.